Hey there, in this video we're going to look at how we can use Python as a calculator. And by calculator I mean doing basic arithmetic like 2 plus 3 times 4. So if we run that, we see we get the result 14, and that already tells us something about what's going on here. If we evaluated 2 plus 3 times 4 from left to right, then that would be 2 plus 3 is 5 times 4 is 20. That's not what we got. Instead, we see Python here is going to follow order of operations. It does 3 times 4 is 12, plus 2 is 14. Okay, so we got your basic calculator, kind of like your scientific calculator. But we can do a little bit more than that. We have your usual addition, subtraction, multiplication, division. Notice that multiplication is an asterisk. It is not an x. If I try to write 3x4, I'm going to get our first error, a syntax error. Because Python will try to interpret x as a variable and say, oh, wait, I don't know what's going on here. So you have to use an asterisk for your multiplication. Anyway, I was saying we have some other operations. We have powers, of course. So if I want to do 2 to the third power, I do that with a double asterisk. So 2 to the third power is going to be 8. We have two kinds of division. So if I do 3 divided by 4, I'm going to get 0.75, which is probably what you're expecting, unless you're thinking like a programmer. If you're thinking like a programmer, you might have been expecting I'd get 0. And the reason for that is that in many programming languages, 3 and 4, as typed here, would be interpreted as a type of variable called an integer. That means it's a variable with no decimal places. And if you do integer division, in most programming languages, your result has to be another integer. So you couldn't have anything with a decimal place. Those languages will drop the decimal place and give you 0. Python, on the other hand, starting with Python 3, and we're using 3.7, at least at the moment I'm recording the video, will assume that you actually want a floating point number. A floating point number is a number that has a decimal place. If you want the traditional throw away the decimal place style of division, that would be 3/4. So if we do that, we throw away the decimal place and we'll get 0. We can also get the remainder from a division. So if I do, let's turn this around, 4, and I use a percent sign here, 3, read that as 4 modulo 3. Modulo means I just want the remainder. So 4 divided by 3 is 1 with a remainder of 1. So the answer here is 1. 5 modulo 3 is 5 divided by 3. Give me the remainder. The remainder will be 2. Modulo is handy for checking if two numbers are divisible by each other. If that's true, then you're going to get 0 for the remainder. So for example, 8 modulo 2 has a remainder of 0 because 8 is divisible by 2. We can use this in our programs as a way to do something every so often. Suppose we have a loop in our program that runs for, say, 1,000 iterations, and every 10 iterations I want to print out the result. I could do that by checking for a modulo 10 in my code. So if I had like a variable x modulo 10, whenever that is equal to 0, then do something. So just looking ahead there with why you'd want to use modulo. So let's suppose now that I don't like the order of operations. I can see how I can type things out, but like just starting right here at the very beginning with 2 plus 3 times 4, and we saw we got the answer 14. But what if I wanted the answer 20? So if I want to force an order to my arithmetic, I can just use parentheses like you would do in written mathematics. So this will evaluate 2 plus 3 is 5, and then multiply 4, giving me the answer 20. Next, suppose I want to do some kind of trigonometry. To do that, I'm going to need functions like sine and cosine, and those are not built into base Python. So if I do sine of 0.5, it doesn't work. It says, hey, sine is not defined. So how do we tell Python how to use sine? We can do that. We just have to import another package. So we use the word import, and then we tell it what package we want to import. In this case, math has our trig functions. Notice that when I typed import, in Jupyter, it changed green. So Jupyter recognizes special words that are Python words, Python commands, and it will color code them for you. And that can be a help. You want to avoid using those special words as your variable names. That can, of course, cause you a lot of trouble. Either it'll give you an error message, or worse, it will replace the name with your variable name and lead to all kinds of confusion. And it just sort of gives you a reminder of did you spell it right. So if I import math, I get the math package. Now, if I put my cursor here on math, you can see over here on the right, I have this window, contextual help opened up. If you don't have this, and you probably don't the first time you open it, go to the help menu and choose contextual help or hit Control I. And this menu will pop up over here. Actually, it'll pop up full screen. Yeah, let me show you. It'll pop up full screen, then you can just grab the tab and drag it over to the right. And so now we have this floating help menu. Anything I put the cursor on, it'll tell me about it. Let's say I want to know what's in the math package. There's a couple ways to do it. Python has a built-in command, dir, I think for directory. If I do dir math, it will print out everything in the math package. A quicker way to do this, since we're using Jupyter, is to type out math, hit dot, and then hit tab a couple times. And it will pop up with a list of everything in the math package, and it'll tell us which things are functions in here. So we have like cosine function, we have an exponential function. It also shows us some things that it's listing as instance, which is just another way of saying regular variable like pi. So I can do math.pi, and it will print out the value of pi, at least to some finite number of decimal places. You have to always remember computers cannot store an infinite amount of information. So we can't store all infinity digits of pi in the computer. It's going to be some large but finite number of digits. So coming back, let's say I want to do sine here. So I'll do math dot, and we saw sine was in there. As soon as I type it out, my help over here gives me the documentation for sine. There's not too much to it because sine's pretty easy to use. I type in the number I want to evaluate with units of radians, and it pops out with the answer to what I wanted. Let's say I want to evaluate multiple things in a single cell. I can do that as well. So if I want, say, 2 plus 3, 5 plus 9, and I run that, what happens here is Jupyter is only going to print out the very last thing from the cell. So I'm allowed to type multiple commands, but I only get a free print of whatever's at the end. That doesn't mean that I can't print 2 plus 3. I can, I just have to manually say, hey, I want you to print 2 plus 3. And so it'll print 2 plus 3. It will also print the last thing in the cell. Now, typically in a case like this, I would manually type out the print statement just so it's more clear to me looking at it what's going on here. But you never really actually have to type print for the last thing in your cell. You'll get that as a freebie, which is nice when you're just doing a quick calculation. So you can put multiple commands. You usually will put multiple commands in a single cell. Last thing I want to talk about in this video is leaving comments. So you may think that a comment is mostly for people, and that is only partially true. The comments are very much for you, the person writing the program. They're not so much for other people, although it does help somebody else looking at the code. If you're doing anything more than a single line type code, you really should think about including one or more comments, especially if it's something harder. If you haven't done it before, you're trying to organize your thoughts. So like thinking ahead, let's say that we want to solve some differential equation and we want to print the result. So the code I would write to do that kind of thing would have this sort of structure. I'm going to leave myself a list of comments, and then later on in the class we can fill them in with the steps to solve that actual problem. To do a comment in Python, I type a hash mark, and anything after the hash mark is my comment. So the first thing I would do in a problem like this would be to define the equations. I would use functions in Python to define the equations. The next thing I would do would be I'd solve the differential equation using one of many techniques that we'll learn about later in this course. And then I would say plot the result. Okay, so this would be like an outline to me. A good idea when you're writing any kind of program is to just outline what you intend to do with comments, and then you can write a few lines of Python code underneath each of these comments, and effectively you've outlined what you meant to do. You can also include comments after a line. So I spell it right here. So I could put a comment after that line. Anything after the hash mark is just completely ignored by Python. It's just English that you want to write in your code. Okay, so that's it for this video. We looked at doing some basic arithmetic, looked at the fact that Python follows order of operations. We can overload that or override that with parentheses. We can get to our trig functions by importing the package math. To use any of those, it's math dot name of the thing we want. We can use comments with hash marks, and we can print things explicitly using the print function.